a train leaves point O and travels 45 kilometers on a bearing of north 25 west. At the same time, a car leaves the same point O and travels 65 kilometers on a bearing of south 55 degrees west. I and J represent unit vectors of magnitude 1 kilometer in the east and north directions respectively. Determine the distance and true bearing of the train from the car. So there are a few things here. Firstly, we need our reference axis to tell us where our positive I and J components are. And we need to acknowledge that we know where north, south, east, and west are. Okay, now what I am going to do is actually move that down a bit because, oh no, I can't do that with that one. I'm moving in a northerly direction and in a southerly direction, so I need to have a little bit of space on my grid. So I'm going to just move my north, south, east, west. There we go. All right, now this is point O. They told us that's where they're leaving, and they travel 45 k's on a bearing of north 25 west. That's 25 degrees west of north. Okay, and that's 45 kilometers, so it's somewhere over, let's do that somewhere over there. And this one is 45 kilometers. And my angle is this angle over there. Okay. At the same time, a car leaves the same point, travels 65 on a bearing of south 55 west. Okay, well, 65 k's in that direction, and that is my 55 degree angle there. Important that we get these angles right, because when we are resolving our vectors into components, if we don't have the right angles, we're not going to have the right components. And then they want, this is important, the distance and true bearing of the train from the car. Okay, so we'll define our variables in a moment, but we know that's our train and that's our car. So that means the word of the train from the car tells us the direction of our resultant vector. So from the car to the train, that's the direction of our resultant vector. And that's very important in terms of being able to find the correct bearings. All right. Now, just in terms of south line and east-west line in, my bearing of my, we'll call that our resultant, define our variables in a moment, that angle in there is my bearing that I'm looking for. Okay, so let's first define our vectors. So let T, that's a T, be train's travel vector. We're talking kilometers. And we'll let C be the car's travel vector. And that's also in kilometers. And we'll let R be the resultant travel vector. And that's also in kilometers. All right. So let's have a look at T. Well, if I created my right angled triangle over here, I've got an opposite, I've got a hypotenuse, I've got an adjacent. To get from the start to the end of my T arrow, I had to move in the positive J direction and in a negative I direction. And so I'm going to have a negative sine ratio for my I component and a positive J component, J ratio, a positive cos ratio for my J component. All right, so T is going to be negative 45 sine plus 45 cos of 25 degrees J. Okay, let's have a look at our cos vector. Well, if I did my right angle triangle again, that's my angle there. I had to move down in the J direction, or negative J direction, and negative I direction to get from the start to the end of my arrow, and opposite hypotenuse and adjacent. So I have got a sine ratio for my I component and a cos ratio for my J component. So C will be minus 65 sine of 55 degrees I minus 65 cos of 55 J. All right, now remember that we can only add our vectors if they're head to tail. And I want to get from the car to the train. So in order to get from the tail over here to the head over there, I need to go negative C plus T. To get my R, negative C plus T. So R is going to be negative C plus T, and because it's all in component form, I can add them and then collect my I components, collect my J components, and sum them. All right, so we've got negative. What's your signs? It's my negative C plus plus 45 cos of 25J. And let's collect our I and J components. So we're going to have 65 sine of 55 minus 45 sine of 25 I plus 65 cos of 55 plus 45 cos of 25 J. And when we have added those together, we get 34.23 I plus 78.07 J. That's my resultant vector. It hasn't answered the question yet. My question is the distance and the true bearing. So we need our magnitude. So magnitude of R is x squared plus y squared, and that's going to be 34.23 squared plus 78.07 squared, and that's going to be 85.24 kilometers. So that's our distance. To find our angle or our bearing, we can create a right angle triangle for our resultant vector. To get that theta, we've got an O, H, and an A. So our tan of our angle is going to be our I component over our J component. So tan of theta is opposite over adjacent. Tan of theta is going to be 34.23 over 78.07. So theta will be inverse tan of that. And that's going to be 23.68 degrees. All right, so therefore our train is 85 kilometers on a bearing of about 24 degrees from our car, and we need to write that. Notice I'm writing approximately to deal with my rounding. 85 kilometers on a bearing of 24 degrees. And if we're writing true, 3 letters or 3 numbers and degrees true, from the car.